Greetings. So this is video number 3. This is Derek Ong. This is video number 3 of how to use SmartPLS in a Windows environment for the analysis of structural equation modeling. Before I continue on with the series, I need to first show you a brief overview of how SmartPLS is used in terms of a process. As I mentioned in my video number 1, that you must always have a theory to help you to build your smart PLS model. Using that theory, then you specify what that structural model is to collect your data and also for your latent variables. Now, when you do your data collection, I will have a separate video that does on how to deal with this problem of common method variance or CMV, which a lot of high-tier publications would like you to check on. Then I will teach you how to estimate the PLS model and algorithm, assessing for the PLS results in the reflective measurement model, um, also for the formative, and I'll have a separate video that talks to you about the difference between formative and reflective measurement models. Then once you have done the measurement model analysis, then you will need to assess the structural model using bootstrapping and of course interpret the results and draw some conclusions. You can also use certain references which I put down here uh, as your guide when you want to write up your analysis later on. So you notice some nuggets of references in my slides. Yeah. So just a brief overview on what I mean by structural model and measurement model. So this is what I mean by the measurement model. If you notice my cursor here, um, this blue color ellipse is what we call a latent variable. Now, you know in social science that a lot of latent variables are very difficult for us to measure. That's why we use the uh, indicator items or the measured items to help to build your latent variables. Yeah, so the yellow rectangles here are the latent variables, and the blue color ellipses here are what we call the latent variables. So latent variables could be anything like intention or motivation or consumption intention and so on and so forth. Uh, so first thing when we do in Smart PLS is always to uh, analyze the measurement model, which is this one. There are three measurement models here, as you can see, uh, and then you measure or you analyze the structural model, which is the inner model. We call this the inner model, which is the kind of like the regression analysis equivalent. Yeah, and you notice that this particular measurement model, the um, arrows are shooting outwards from the ellipses, which indicate that these are reflective loadings. And for the formative, these are the arrows that are going in, which indicate the formative weights. So I will have a separate video that talks about the difference between formative and reflective. So a path model, when we just look at only the ellipses, will have the indication of the hypothesis between the variables of the exogenous and the endogenous constructs, as you can see here, which we use mostly for hypothesis testing. Measurement model, when we run the PLS, this would roughly how it looks like, yeah, with the blue color as the constructs and the yellow color as the indicator items. So we're going to first start with building our measurement model or building a model in Smart PLS. And I'm going to show you with this example called the technological adoption. If you notice, there are four, if you want to call this the uh, uh, independent variables, and then of course you have your dependent variables. Now you notice that there are two dependent variables here. That is why I mentioned in my first video that Smart PLS is a great, or structural equation modeling is a great way to model more complex models that goes beyond just the normal regression analysis. So that's why people use structural equation modeling now on, which models more the real world in social sciences. So to begin with, I first have to show you how to save your file as a CSV file, or what we call as the comma separated value file. Okay, so this is an SPSS file which we have collected the data on the adopt project. So what you do is you just go to file. Now this is very important because PLS only recognizes um, comma separated value file. So please make a note of this if you're a PhD student or a research student trying to do your analysis. So file, save as. Um, I'm just going to call this adopt. Yeah, and I am going to create a new file. You can either create a new file or overwrite the file, but make sure you save the type as CSV. I'm just going to call it CSV, adopt CSV. And I'll write the variable names to the spreadsheet, and then I press save. Okay, and if you notice, if I were to open up the data set of adopt, the one that I've just saved, it is in an Excel form, but in a form of comma separated values, and this is how it looks like. Okay, so the next thing we do is to show you how to import the data into PLS. So this is your PLS. When you open up your PLS environment, always create a new project. Since I'm going to call this project adopt, so I'm just going to adopt. There you go. And it will open up a thing here to import data. Of course, I can't build the model without importing data, so I have to import the data first. So double click to import data. You found the adopt. Yeah, like I said, it only recognizes CSV, so please find the CSV file that you've saved it. Importing. You can name this adopt. And you notice that all the indicators here are all right. Okay, with no missing values. As I mentioned in my earlier uh, video, there should not be any missing values. They even calculate the mean and median and standard deviation. Now, isn't this wonderful? Um, that's why I like SmartPLS so much. Okay, right. Now, when we do that, make sure that we built our model, and I'm going to show you, just trying to figure out what's that model. This is the model. So technological readiness, top support management, cost, competitive pressure, technological option, and file performance. So my next video will show you how to build this model. So remember this model, and for now, just remember how to save your file and to open up into and transfer the data set into your file. All right, thank you.